Hello, this is the video for solving absolute value inequalities. And so the procedure is here, and you can look back at it because it's not going to make a lot of sense until you see an example. So I'm not going to read that through. I'm just going to explain as we go through an example and kind of come back to this. So let's take a look at the first example here. Um, so this is an absolute value inequality. Now we've already gone over how to solve absolute value equations. So you might remember that this is a very common error. Sometimes people want to do -8 minus 3 is -11 here. That's a violation of PEMDAS. So you want to multiply before you can combine these with addition and subtraction. Okay, so you can't do that. You also can't distribute in. You can't multiply the 3 inside of absolute value. So these bars are not like parentheses. What you have to remember to do with absolute value equations and absolute value inequalities is you have to isolate the absolute value. So it starts out being the same as absolute value equations. So I'm going to add 8 to both sides. And that gives me -3 times absolute value of x minus 1 is greater than or equal to -24. Then I'm going to divide both sides by -3. And we learned with linear inequalities, when you divide by a negative, you have to change the direction of this inequality sign. Okay, so now we have an absolute value inequality. So we have to, just like we do with equations, we have to analyze this absolute value inequality. Okay, so let me go to the directions here. The procedure, isolate the absolute value. Okay, now just like with equations, you're going to write two inequalities, but the rules are a little bit more involved. Okay, so remember, you have a positive condition and negative condition. Well, you're going to have that, but you're also going to have to choose whether it's an and or an or. So the word in between the two inequalities is either going to be an and, which means both of the results have to be true, or it's going to be an or, which means that either result can be true. Okay, so you decide whether it's an and or an or by looking at the inequality after the absolute value has been isolated. And if it's a less than or equal to, it's going to be an and. So I think of it as less than, it's going to be an and. And if the inequality is greater than or equal to, it's going to be an or. So I think of the words greater than. So it's an or. Okay, so this is going to be the word and here, because this absolute value is less than or equal to 8. Okay, so the word is going to be and. Now you might remember there's a positive condition and a negative condition. Same thing here. So we're now analyzing the absolute value now. So we're going to lose the absolute value and just write x minus 1 is less than or equal to 8. So you just copy down the inequality without the absolute value bars. It's less than, so it's and. Okay, now if you remember with equations, we took it out of the absolute value. You don't change the sign inside. And you change that sign of that 8. Well, if you remember from dividing by -1, if you multiply or divide by -1, you have to switch the signs. Well, if I'm going to change this 8 to a -8, then I also need to change the sign. So that's going to change to a greater than, and then it's going to be a -8. Okay, so what just happened? So you can look back at this. Okay, so you write two inequalities by the following rules. First, you take the expression out of the inequality and write the inequality unchanged. That's the positive condition. And then you choose the words and or, and we chose and because it was less than. Then you're going to write the second inequality to remember to change the inequality direction, and you're going to change the sign of the number after the inequality. Okay, that's a lot. So what I do is I say to myself, with absolute value inequalities, I have to remember three things. I have to write the word, I have to change the inequality, and I have to change the sign of the numbers. Okay, so now we're ready to solve this inequality. So that's going to be x is less than or equal to 9. And I'm going to add 1 here and get x is greater than or equal to negative 7. Okay, so now we're going to deal with what does the and mean. Well, if we draw a number line with the key numbers negative 7 and 9, and then we graph both of these on that number line, x is less than or equal to 9 means the 9 and then everything to the left of it. Okay, x is greater than or equal to negative 7 means the negative 7 and everything to the right of it. And here is what and means. And means the intersection of those solutions. So the part that is true for both of those. This has to be true and that has to be true. The only time they're both true is this little line segment starting at negative 7 to 9. Okay, so in interval notation, the solution is negative 7, comma 9. Now the good news is this is what I call a classic and. And so if you have an absolute value and it's a less than or equal to, it's going to end up looking like a little line segment every time. Okay, so let's try number 2. Okay, so again, you have to isolate the absolute value. So this absolute value is being divided by 4. So I'm going to multiply both sides by 4. That's the absolute value of 2 minus 3w is less than or equal to 8. Okay, so now absolute value is going to have 2 inequalities. The first one you just copy down without the absolute value. So we have 2 minus 3w is less than or equal to 8. Then you have to decide, is it an and or an or? And if it's a less than, it's going to be an and. Okay, that's number one thing to remember. Do you remember the other two things? Then it's going to be 2 minus 3w. Don't change that sign. You change the inequality, and then you change the sign of that 8. Okay, so then if we solve that, that 2 is positive, so that's going to be minus 2, negative 3w is less than or equal to 6. Divide by negative 3, but then u divided by negative, so you have to switch the inequality. So you get w is greater than or equal to negative 2. All right, over here, minus 2, negative 3w is greater than or equal to negative 10, but you're going to divide by negative 3. So you switch the sign, and a negative 10 divided by negative 3 is 10/3. Okay, so let's just do a number line one more time so you can see what's happening. This negative 2 and 10/3. W is greater than or equal to negative 2/3 goes that way. W is less than or equal to 10/3 goes to the left. And it's an and. So that means we're looking for intersection. This has to be true, and that has to be true. The only place they're both true is that intersection. So this solution is bracket negative 2 to 10/3. Okay, now let's do an or one, and we'll see the difference. So we have the absolute value of 4 minus 3c is greater than or equal to 6. So we have to isolate the absolute value. Well, that's already done. So we're ready to analyze the absolute value. So there's going to be 2 inequalities. First one, you just copy it down without the inequality. Okay. Then you need to decide on the word. And this time you see the greater than. So this is an or. Okay, so then you have 4 minus 3c, copy that down, don't change that sign, but then you change the inequality, and the sign of the 6 is negative 6. Okay, so we'll solve that. We have minus 4, negative 3c is greater than 2. Then we have to divide by negative 3, so that means we have to switch the sign. So if c is less than negative 2/3, over here, -4, -4. So we have negative 3c is less than negative 10. Then we're going to divide by negative 3. So when you divide by negative, you have to switch the sign. And that's going to be 10/3. Okay. And the word is or this time. Okay, so let me draw a number line and explain what or means. So our key numbers are negative 2/3 and 10/3. And this graph, C is less than negative 2/3, means an open circle on negative 2/3 and all the numbers to the left. And this graph means C is open circle on 10/3 and all the numbers to the right. C is greater than 10/3. But this is an or. Okay, so an or is different than an and. An and means intersection, or what the values are that make both of the inequalities true. That's what and means. And or means union. Well, what does union mean? Union is just a collection of all possible solutions. Okay, so an or, you don't need an intersection. You're just going to collect all the solutions. So there's a solution set over here, a little piece of the solution set here. And then there's some solutions over here. So when you graph that, you get these two rays going in opposite direction. And that's a classic or. And so the interval notation for that would be negative infinity to negative 2/3, parentheses, because it's all open circle, union 10/3 to infinity. So that's what I call a classic or. They look like that. Classic ands look like intersections. Okay? All right, so let's go to number 5, because this is another or. Okay, so we have absolute value of 2c plus 6 minus 8 is greater than negative 4. So the first step is we have to isolate the absolute value. Very important that you do that first, because you can't analyze it till it's all alone. So we're going to add 8 to both sides. And that gives me absolute value of 2c plus 6 is greater than 4. So now that I've isolated the absolute value, I'm going to have two inequalities. The first one is the positive condition. It's just what the inequality is without the absolute value. Then you decide on the word, and it's a greater than. Okay, so that's an or. All right, then you take it out of the absolute value, and this is the negative condition. So you're going to change 4 to negative 4. That's why you also have to change the inequality. So the word is or, change it to less than, make it a negative 4. Okay, and it's going to look like this when we're done. I'll show you. 2c is greater than negative 2, so divide by positive 2, so you don't have to switch the signs. You get c is greater than negative 1. Subtract 6 over here, you get 2c is less than negative 10. Divide by positive 2, so you don't need to switch the signs. You have c is less than negative 5. Okay, we graph it. Here's negative 5, and here's negative 1. C is greater than negative 1 is all the numbers to the right of negative 1. C is less than negative 5. That's all the numbers to the left of negative 5. And I went ahead and did the final answer because it's an or. And or means you just collect all the solutions. So that's what the number line looks like. Don't forget to put it in interval notation. So I'll write the answer right here. So it's negative infinity to negative 5 union negative 1 to infinity. Okay, so try 4 and see if you can do it. So pause the video and try it. Okay, now if you tried it, something interesting is going to happen. Did you know that you need to isolate the absolute value? So divide by negative 4. Okay, so that gives you absolute value 4 minus x. Now you divided by negative. Did you switch the sign? And then negative 12 divided by negative 4 is 3. All right, now once you have that, now it's time to analyze the absolute value. We know absolute value is going to have two conditions. The positive condition, you just write it down without the absolute value. Then you have to decide on the word. This is a less than or equal to, so it's an and. And then 4 minus 3x. Don't change the sign in there. Change the inequality and the sign of the number on the outside. Okay, so now it's trying to solve. So this 4 is not negative. This 4 is positive, right? That minus belongs to the x. So hopefully you subtracted 4, and that gives you negative 1x is less than or equal to negative 1. So dividing by negative 1, you're going to have to switch the signs, and you get x is greater than or equal to 1. Here, if you subtract 4, you're going to get, you understood 1, negative 1x is greater than or equal to negative 7. But then when it's time to divide by negative 1, you're going to get x is less than or equal to 7. Because you have to switch the sign. Now this is an and. So let's see if the graph works out. It's going to be a classic and, I think. So this is going to be a 1 and a 7. And x is greater than or equal to 1 is all the numbers to the right of 1, including 1 this time. And x is less than or equal to 7 is all the numbers to the left of 7, included 7 this time. And it's an and. Okay, and means intersection, so that's the numbers between 1 and 7. So the solution to this one was bracket 1 to 7. How did you do? Okay, now don't pause it for 6, because 6 and 7, there's going to be something interesting that happens. But again, I do want to point out, can you add 4 plus 5? That is so tempting for students. But remember, this is 4 plus 5 times the absolute value. You cannot add those together because PEMDAS says you would have to multiply first, which of course you can't. That doesn't mean you're going to be able to add. So what you have to do is isolate the absolute value. So we're going to subtract 4, 5 times the absolute value of 2y minus 7 is greater than or equal to negative 4. Okay, divide by 5, and you get absolute value of 2y minus 7 is greater than or equal to negative 4/5. Okay, now you could continue going on and doing the algebra. But if you really take to heart that you isolate the absolute value and then you analyze the absolute value, you can analyze this answer just by thinking about it. So what you can do, you remember absolute value, the definition of absolute value is the distance some number is from 0, and it's never negative. So this side of the equation is always going to be a positive number or 0. No matter what. As soon as you have isolated that absolute value, you know that side is going to be a positive number or 0, because that's what you know about absolute value. So no matter what you put in for y, if you put in negative 2, you get negative 11. Absolute value of negative 11 is positive 11. If you put in positive 2, you get negative 3. Absolute value of negative 3 is positive 3. It doesn't matter what you put in for y, you're going to get positive. And remember, solving means what's the value of y that makes a true statement. And so when you have absolute value greater than or equal to a negative number, then the answer is all real numbers, which would be negative infinity to infinity. So if you isolate your absolute value and it's greater than or equal to a negative, it's just always going to be all real numbers. All right, so keep that in mind. And then this one, let's isolate the absolute value. So that would be absolute value of 2y minus 7 is less than negative 1. Same thing. Once you've isolated the absolute value, you analyze the absolute value, and there's not a lot of work. We know that absolute value is always going to be a positive number or 0. So this statement you might as well read as this is a positive number or 0, no matter what you put in for y. So is this statement ever going to be true? No. So this one is no solution without doing any work, because there's no way an absolute value can be less than a negative number. So keep an eye on those, because you might save yourself some work there. Okay, I want to keep this video short, so why don't you go and work on all the absolute values on page 28 or behind this page. But you can stop right now or you can listen to this. I do want to tell you that these last two that didn't do any algebra, the algebra supports this. So if you want to watch, you can watch me. I'll just do it for this one. If I do the algebra here, I'll have 2y minus 7 is less than -1 and 2y minus 7 is greater than +1. So that would give me 2y is less than 6, which is y is less than 3, and 2y is greater than 8, or y is greater than 4. So if I graph that on a number line, then y is less than 3 goes this way, and y is greater than 4 goes this way, and it's an and. So is there any intersection? No. So there's nothing on the number line. That's no solution. Same thing here, you would get the whole number line colored in. So that's why the algebra works, but I would say think about absolute value is always positive or 0, then you can analyze it without, you can get a solution without doing any algebra. Okay, if you want to check your answers, this is an and, so parentheses -4 comma 2/3. Did you catch this one? It's all real numbers, -infinity to infinity. This one, -infinity to -2/5, union 14/5 to infinity. Number 4, parentheses 3/2 comma 2, because this is an and. That was an or. I didn't do the number line, but you can if you want to understand. This one, -infinity to -1, union 5/3 to infinity. And this one, -infinity to -2, union 7 to infinity. This would be an example of what a test question might look like if we ask you to explain. So I wrote that this is all real numbers because absolute value is always positive or 0, so any value of x is going to bring a true statement.